frequency also. I took one question from GATE 2003. CT is 5 cos 2 pi into 10 to the power 60. Modulated by MT is cos 4 pi into 10 to the power 3t. To generate an AM waveform, modulation index used here is 0.5. Calculate PSB upon PC. Sideband power upon carrier power. For calculation of sideband power formula is PC mu square upon 2. Total sideband power upon carrier power. I cancel out these two terms. Mu square divided by 2. Mu is already known to us. 1 by 4, 1 and 2 and means 1 by 8 is our answer. Very simple question in GATE. The sideband have 25% of total power if mu equals to 0.5. I took one more question. Peak amplitude of AM vary between 5 to 15. Calculate PC, sideband power and total power. If peak amplitude vary between mu is vary between some value 5 to 15 means it shows Vmax or Vmin. These terms are given to us. Vmax from our basic expression A cos omega ct. Our peak amplitude from expression is 1 plus mu, 1 minus mu. Ratio of these two is Vmax upon Vmin, 1 plus mu, 1 minus mu equals to 15 divided by 5. 3. Use component to divisor to solve expression for mu. We get value of mu is 0.5. Then we can calculate the other values. Total carrier power easily calculate from this idea, and we can calculate other value also. Vmax is this term. We can calculate carrier power if we know carrier amplitude. Carrier amplitude come from these two terms, Vmax and Vmin. If we add Vmax and plus Vmin, then we get result A equals to Vmax plus Vmin divided by 2. Vmax 15 plus 5 divided by 2 is our solution is 10. For PC, 10 square divided by 2. If antenna resistance is R equals to 1, PC equals to 50 watt. If PC equals to 50 watt, the PT easily calculated from this expression. 51 plus 0.5 square divided by 2. By solving this expression, we get result 56.25. Sideband power means carrier power minus from total power. So we get sideband power. We can apply formula also here. Result will be same. Now we start with multi-tone amplitude modulation. Amplitude modulation. For multi-tone amplitude modulation, where message signal is not single sinusoidal frequency, it is more than one sinusoidal frequency, maybe 2, maybe 3, and more than that. we took this type of assumption again here, and modulated signal come from this expression a m1t m2t m3t and so on multiply with cos omega ct. Complete term is multiply with cos omega ct. All three message signal can be all this type of term trigonometric function am cos omega m1t m2t m3t and so on. If more component is there, st is a cos omega ct plus mu 1 a by 2 first term cos omega c plus omega m1t is upper side band, same lower upper side band due to m1, lower side band due to m1, upper side band due to m2, lower side band due to m2 and so on. These terms may be increasing. If single tone, remaining term are not present. If it is multiple tone, as per frequency per individual component increment, two term upper sideband term and lower sideband term added to the system means one frequency single frequency increase means two term is added to the system. Four frequency increase means eight term is added to the system. New value of mu1 mu2 mu3 is mu1 is a m1 upon a, mu2 is a m2 upon a, mu3 is a m3 upon a, where mod of this mu1 square, mu2 square, mu3 square. Modified modulation index can be represented in this way. Total power formula is also revised mu modified. So all the formula are revised due to modification in mu. Remaining formula of efficiency is mu modified square upon 2 plus mu modified square. So all formula are revised because AM is a linear modulator. How it is linear? Effect is accumulating. If only single frequency, three term carrier upper and lower. If double frequency, two term are added to the system. One more frequency, two more term. Just it is adding the term. Means in the spectral diagram we can draw in this way. For multitone we can draw a spectrum in this way. We segregate all the term. If we add two term for transmission, this term added one upper sideband and lower sideband. If we add one more frequency upper sideband and lower sideband, same in negative side also. If one more frequency upper sideband and lower sideband, upper sideband and lower sideband, this spectrum is spread in frequency band. So bandwidth for this we can calculate from higher frequency component and lower frequency component. Difference between higher frequency component and lower frequency component. If we assume there are three frequency, highest frequency component is omega c plus omega m3 and lower is omega c plus minus omega m3, then omega c plus omega m3 minus omega c minus omega m3 create the difference twice of omega m3, that is our bandwidth. In this case omega m3 is greater than omega m2 is great omega m. In this case omega m3 is highest modulating frequency. If it is reverse, Then bandwidth for this scheme is omega m3 m1, twice of omega m1. Bandwidth can be calculated for AM in this way: highest frequency component omega c plus omega m minus omega c. If it is single tone, we can directly conclude the bandwidth is twice omega m. Bandwidth is double of highest modulating frequency. In the multi-tone, we consider in this way. We took a question from gate 9, 2 marks question. A message signal mt is half cos omega 1t amplitude modulated with a carrier omega c to generate st equals to 1 plus mt cos omega ct. What is the power efficiency eta is? Resultant power efficiency of this modulation scheme. This is the case of multi-tone. There are two type of frequency. Multi-tone case. If it is a case of multi-tone, means mu is modified. Mu is modified due to first component and all due to second component. Modified mu is mu1 square and mu2 square. Mu1 come from am1 upon a is mu1. Mu1 come from half square of it. Mu2 come from half square of it and root. Half square is 1 by 4 plus 1 by 4 means half equals to 1 upon root 2. Then efficiency mu modified, it is modified due to double frequency. Modified formula for efficiency is mu modified square upon 2 plus mu modified square. 1 by 2 upon 2 plus 1 by 2 equals to half upon 5 by 2. 1 by 5 is 20%. Now in this case, modulation efficiency in multi-tone is 20%. Now we discuss one more question. ST is A AM cos omega MT cos omega CT, where PS denote power in any one sideband. The question from DRDO 2009. PT is total power. In this waveform, some relation is given to us twice AM. AC equals to twice AM. Calculate relation between PT equals to blank PS. Value of this blank is, we can calculate, because power of any sideband, we have formula for that. PC mu square by 4. PT, we have another formula given to us, a standard AM waveform. Relation between AM and AC is half, which is known as mu. If we knew about mu, we can directly relate it. We want relation between these two by putting value. We get relation is PC upon 16 and 9 by 8 PC. We want relation between these two. Eliminate PC. PS upon PT equals to 1 by 16, 9 by 8, 1 by 18 means PT equals to, directly we can say, 18 PS. In this question mark we fill 18. Now we will discuss envelope term in AM. What is envelope? A cos omega CT plus K MT. This is standard expression for AM. Cos omega CT A plus Ka MT. We generally took AKA equals to 1. Carrier amplitude and amplitude sensitivity of modulator. This is 1. A plus MT is known as envelope. Any term multiply with the carrier component after modulation is part of envelope. Envelope should be greater than 0. One more idea, if we can represent in term of mu, this is known as envelope. Envelope amplitude. Envelope amplitude. If we draw a signal, we want to modulate this signal for all value of t. This is a basic a value and a plus mt. If we apply some carrier on it, then result will be this way. We get envelope a plus mt and its modulation scheme. Message can be recover. If it is so, if it is not following this condition, a plus mt is greater, not greater than, maybe less, some portion, not greater than. Rewrite not greater than means waveform may be in this way. Once this type of pattern is available to us, then I apply modulation on it. At this juncture, phase reversal is occur. Due to phase reversal, this signal can't be reconstructed. Due to phase reversal, this signal can't be reconstructed. So a plus mt should be greater than 0. This envelope should be greater than 0 to make signal reconstructable. There is some phase reversal due to negation of the magnitude. Due to negative, cos is multiplied with a negative quantity. Magnitude is not affected, but phase is change of the carrier. Cos omega ct is now phase reversal due to negation in the magnitude. Now we will discuss the generation of AM wave. There are two ideas to generate AM wave: switching modulator and non-linear modulator. Switching modulator is high power modulator. Non-linear modulator is low power or square law modulator. square law modulator. For modulation, at least 1 degree of nonlinearity is required. 1 degree of nonlinearity is required. We can achieve 1 degree of nonlinearity through multiplication. We can achieve 1 degree of nonlinearity through multiplication. XAM is CT multiply with MT. MTCT. 1 degree of nonlinearity is available in this. We make a diagram for switching modulator and proceed further. Block diagram of switching modulator is two type of input, message signal and carrier component, applied to a switching device and passing through a band pass filter. Band pass filter is tuned at omega c, which minimum bandwidth is omega c plus omega m, omega c minus omega m, which minimum bandwidth is twice of omega m, to for the generation of AM waveform. So we start with this idea how switching modulator work. Combination of these two apply on switching modulator. We took some assumption here. Carrier frequency is always above than message signal frequency. Means driving frequency is carrier frequency. Message signal frequency is put on into the carrier frequency. This is the basic idea of carrier frequency. Means carrier frequency is dominating frequency. Carrier frequency decide about the switching device. Means switching device is driven by carrier frequency. If switching device is diode, it may be BJT, FET, any type of switching device. If we consider it is diode, it works for only positive half cycle of the waveform. On negative half cycle, it does not work. So in this way, it produces a pulse train. We already know if it produces a pulse train with frequency is drive by carrier component, carrier frequency. We already know this carrier component have distinct frequency component via Fourier series expansion. Pulse train has Fourier series expansion, all the basic frequency and its harmonics. Fourier series represent its basic component, fundamental component of frequency and its harmonic. So I directly write impulse train Fourier transform Fourier series expansion is 2 upon pi a cos omega naught t 1 by 3 cos 3 omega naught t 1 by 5 cos 5 omega naught t, and so on. We multiply this term with mt plus ct. If we multiply this term, we get lot of harmonic terms. We get all these terms after multiplication, and after passing through a band pass filter, out of these components some component may pass. This is low frequency component, original message signal, which is baseband signal, which is not part of band pass filter. It does not pass. This carrier component tuned at omega c, it always pass through band pass filter. This is multiplication between MT and CT. It is desirable component for us. If multiplication between MT and CT, this is required amplitude modulated signal. This is also passed through this band pass filter. It this component is double of carrier frequency. We are working on carrier frequency. Double of carrier frequency means does not pass. In this case, triple of multiply means add and subtract, means this does not pass. Desirable component can be generated through switching modulator and combination of band pass filter. Appropriate band pass filter center at carrier frequency. So final result at the output of switching modulator is AC by 2 A by 2 cos omega ct 2 upon pi mt 2 upon pi mt cos omega ct.